In this lesson, we're going to learn how to factor trinomials that have a greatest common factor. We'll just abbreviate greatest common factor and just say GCF. So if you look at this example, you might notice that A is no longer that invisible 1. Instead, it's 2. All right? We want to see if every other term can also be divided by 2, because that's what a greatest common factor is. It's the largest term that all the other terms can be divided by. So 2 can go into 2, 2 can also go into 14, and 2 can go into 20. So our GCF is 2. Say that again. 2 is the largest number that all of the terms could be divided by. So that's our GCF. So we're going to factor that out. So I'm going to write the 2 just out here. And then I'm going to go ahead and divide all of the terms by 2. So all 3 of these terms are going to get divided by 2. So I make the parentheses. 2x squared divided by 2, the 2's just cancel out and I get x squared. 14x divided by 2 will be 7x, because 14 divided by 2 is 7, and I bring down the x. And then I have 20 divided by 2, which is 10. So what I just did was kind of like the opposite of distribution. Instead of multiplying each term by the number on the outside, I divided every term by the number and put it on the outside. Because remember, I'm factoring, I'm breaking things down. So after we factor out the GCF, we want to see if what's inside the parentheses can be factored. So we have a trinomial, and 10 is C. So I'm going to put that at the top of my diamond. And B is 7, so I need factors that will add to 7. So go ahead and pause and try to think of two numbers that multiply to 10 and add to 7. Go. Okay, those two numbers are 2 and 5. So I need to keep my 2 on the outside. I need to keep bringing it down. I can't forget that. And now I can factor this trinomial because I know the two numbers. So I had positive 2, so I say x plus 2. And I had positive 5, so I say x plus 5. And that is my final answer. To quickly recap, the first thing we did was we factored out the GCF, which was 2. We wrote it on the outside and we divided every term by 2. Then we had a trinomial, so we factored it just like we did in the lesson before using the diamond method. We made sure to rewrite the GCF on the outside, and then we wrote our 2 factors. If you feel like you understood this, go on to the next example, so keep watching the video. If not, I would go ahead and rewind and rewatch this to make sure it makes more sense. Our next example is x to the third plus 2x squared minus 15x. Notice that what we would say is a here is again an invisible 1. Okay? However, each term has an x in it. So we can divide each term by x, so our GCF will be x. So I write that on the outside just like I did before, and I'm going to divide every term by x. The exponent for this x is like an invisible 1. And that's important because when I divide terms with exponents, I subtract the exponents. So, x to the third divided by x to the 1 is x to the 2, because 3 minus 1 is 2. 2x squared divided by x is positive 2, I just bring down that 2, x. 2 minus 1 is 1, so there's like an invisible 1 here. And then finally, negative 15x divided by x. I bring down the negative 15. And x divided by x, those will just cancel out. And so that's what I have left. So now I have my GCF on the outside, and now I have a trinomial here that I can try to factor. So I go ahead and I make my diamond, and c is negative 15, so I write negative 15 up here. and b is 2, so I write 2 at the bottom. So pause and try to think of factors of negative 15 that add to 2. So hopefully you came up with 5 and negative 3. So it's very important to remember to write my GCF on the outside, and now I write my two binomials, which will be x plus 5 and x minus 3. Now everything is factored completely, so that's my final answer. Press pause and make sure you have this copied down before you go on to the last example. In this last example, we're going to see when a GCF can include both numbers and variables. So my first coefficient is 3, so I'm hoping everything can be divided by 3, so let me check. 12 can be divided by 3, and 9 can also be divided by 3. So 3 will be a part of my GCF, but I also need to check for variables. Notice they all have an x, alright? But even more than that, let's look at the exponents. I have 4, 3, and 2. When all terms have a variable, the GCF is going to be that variable and the lowest exponent that we see. The lowest exponent is 2, so we say 2. The same thing was true in our previous example, but the lowest exponent was like that invisible 1, so our GCF also had that invisible 1. Just like before, I write my GCF on the outside, so I say 3x squared, and then all three terms have to get divided by 3x squared, and then they'll go in the parentheses. So it's best to take this in kind of in two steps. Take care of the numbers, then take care of the variables. So I'm doing 3x to the fourth divided by 3x squared. 3 divided by 3 is just an invisible 1. Okay, so I go to the variables. X to the fourth divided by x squared is going to be x, and 4 minus 2 is 2. So therefore, 3x to the fourth divided by 3x squared is x squared. Now I have to do 12x to the third divided by 3x squared. 12 divided by 4 is positive 4. X to the third divided by x squared is going to be x to the 1, and I just leave that 1 invisible. And then 9x squared divided by 3x squared, so I have 9 divided by 3 is positive 3. And x squared divided by x squared, those cancel out, so there's no x in the last term. So now I have my trinomial. If you look at it, I'm going to need factors of 3 that add to 4. So I set up my diamond with 3 and 4. Pause and try to figure out the factors of 3 that add to 4. So those two factors should be 1 and 3, because 1 times 3 is 3, and 1 plus 3 is 4. So I make sure that I write my GCF on the outside, and then my first factor will be x plus 1, or you put x plus 3, and the second one will be x plus 3. And that is my final answer. If you need to, go back and rewatch an example. If you feel comfortable, go on to the practice. Good luck.